What's going on, everyone? Welcome back to another episode of Crypto Catch Up with me, Benny. We're going to be doing a two-part series on scaling blockchain. So I've aptly called it the state of scale, and we're going to be looking at projects and the proposals from such projects and how they're looking to scale their solutions on-chain, off-chain, directed to cyclic graphs, and maybe a little bit into the dApps later on. We'll see how we go for time. But we're breaking it up into two parts so you can watch on-chain first, off-chain and DAG second, to obviously make it easy for what your everyday life demands. So let's get into it. Alright, so some of you might know what this is, and if you don't, well, CryptoKitties came out in December 2017, and it's a game. It's a game that allows you to buy, sell, and trade and evolve CryptoKitties. It's based on Ethereum, and it single-handedly took Ethereum to this. Near 95% block utilization at the end of 2017, early 2018. And that's because of the way Ethereum handles transactions. Essentially, this CryptoKitties game was super uber popular, and people were obviously doing a hell of a lot of transactions at the time. But this is only one small game, and insignificant you would imagine, but it's something which obviously brought to light how bad the scaling is of some of these platforms now, and what we're going to do about it. So let's get into that. So what are we talking about that's missing? Well, we're talking about that it's missing a red Ferrari. No, that's not the case. We're talking about that it's missing speed. So throughput, the ability to process multiple transactions in parallel. So currently, all the blockchain solutions essentially process them one by one in a logical linked list of transactions that are time-stamped, that because of the way that it's structured in a blockchain, block after block after block, it doesn't allow for us to handle large volumes of transactions at any one time. So to give you some context, on the left you have Twitter. Twitter does around 8,000 tweets per second. Facebook, around 52,000 likes per second. Majority are not on my feed, that's for sure. Visa, it averages around 2,000 transactions a second and can scale all the way up to around 60,000 transactions a second, depending on the media you read. And the big kahuna in the corner, if you can see it where my camera will be sitting, but that's Google. Google searches, 69,000 transactions a second. And with Google searches, it's said that your search, every single one of them, will hit at least 1,000 different CPUs and travel an average distance of 1,500 kilometers back and forth to retrieve that to you in 0.02 seconds, which is quite impressive. And the way they do that is with raw power, horizontal raw power. Horizontal this way because they get more computers to break it up and to do those for you. So if you're getting some portion of the return result from here, some from here, some from here, it makes it a lot faster. That's what we're going to have a look at. So can anyone guess out there Bitcoin, Ethereum? Well, I know you're all wanting to jump through the camera, but you can't. So I'm going to tell you. Bitcoin averages around 2 transactions a second, and it maxes out at around 7 to 10. And the reason for that is because it has a block size of 1 megabyte. Now that block size limits exactly how many transactions can fit in a block at any one time, because each transaction is around 256 bytes. You look at Ethereum, and that maxes out at around 15 transactions a second. It's not limited as such by the actual block size, but it's limited in computational power that it can utilize in each transaction. Because it is a world computer and it allows you to run smart contracts, they've had to put a gas limit per transaction to stop, obviously, this world computer having to process crap code that could have an endless loop in there, which would obviously cause the network to crash. So we all know, and if you don't, it's something that you'll find out really quick in this space, that blockchains have been built to have 2 parts of the 3 of what's known as the trilemma, or the impossible trinity. So they have security and they have decentralization by nature. Now, we can obviously argue all of that, but we're not going to in this video. So what are we still lacking? Well, we're lacking exactly that, the speed. And Vitalik Buterin has actually said that he doesn't believe it's possible to have all three at an equal trade-off. So obviously, if you want to get some speed, you might have to give up some security, or you might have to give up some decentralization. And we'll talk about that with the pros and cons of each of the solutions we're going to be looking at with the on-chain. So strap yourselves in, because Bitcoin and Ethereum aren't giving up their fight. So how do we take a network that's decentralized, it's open, it's censorship resistant, secure, transparent, and it's a global network, and make it scalable? Because it's the fact that it's a global network and it's decentralized that it's slow. Because centralized services obviously don't have to get consensus from everyone around the world. And because of that, they can do it real time, on premise, nice and easy. Well, let's talk about the different on-chain solutions. And like I said, in part 2, we'll be able to talk about the off-chain solutions. So layer 1, on the protocol itself, you've got BlockSize, Sharding, and consensus. So some, I guess, benefits of this is that you're changing the base protocol. Now, some will argue that you should never change that, but that's not what we're here to say. We're here to present to you the options for you to formulate your own opinion. The second is you're increasing the capacity of the core chain without having to go off-chain to do it, and it maintains integrity and security. Once again, an arguable factor. Really though, it's short term. It's mathematically linear. So for example, the block size, if we double it, it will only gain to the point when it hits that upper ceiling of that next block size increase. Then you have to go again and go again. It is obviously limited by that. And you can get things like blockchain bloat, which we'll talk about with the very first one, block size. So, block size. It is probably the easiest in terms of understanding what's going on. 1 megabyte, you can have 1,000 transactions, let's say. Well, if we simply double it, it means that we can have 2,000 transactions. Now, on-chain is something that Bitcoin Cash is doing. They believe in going all the way up to terabyte blocks, and then we have the pros and cons of that. So the pros of it is the fact that it does require a hard fork, which, you know, is arguably not a pro, but it's something that as long as you can garner community consensus of miners, etc., you'll be able to implement that change. From a protocol standpoint, it is a lot less complicated than sharding or anything else, for example. From the downside of it, though, is that you start to have centralization, and this is fact. Once we start talking about banging out 1 terabyte blocks every 10 minutes, unfortunately, people like you and I, unless you're a rich corporation, will not be able to be the fully validating miners on the network. So mining for an actual profit, we simply won't be able to do that. We can still verify through, you know, SPV wallets, simple payment verification, but you can't compete for the block rewards or anything like that. You simply will not have enough storage capacity at home, enough network bandwidth or anything to propagate and to store that, which is where we talked about blockchain bloat earlier. Obviously, storing 1 terabyte every 10 minutes, it's a huge amount of data. I don't even have that inside my PC. I only have it on external drives. So it's one of those things that as we go along, obviously hardware like storage does become cheaper, but not at that rate. Not at 1 terabyte every 10 minutes. It's simply out of scope for everyday consumers. I would argue that to the cows come home. What about sharding? Well, sharding is one of the promising things that is coming out. A lot of projects are saying they're going to look to shard. Now, sharding is not a new concept. Sharding has been done in databases for many, many years. Now, if we look at Ethereum as a use case, nodes actually hold the entire state of the chain at any one time. They have to process every single transaction. So, for example, with our CryptoKitties, if we were to, you know, upgrade our little CryptoKitty and sell it and buy some, every one of those transactions has to be propagated and essentially agreed upon by everybody in that network. So if that's 100,000 nodes or computers around the world, that's a lot of people that we have to get in agreement over a vast distance. transactions are in sequence and they're not parallel. So like we said before, one by one by one, not 10 here, 10 here, doing a Google search and then returning the same results and collating it at the end. So essentially, it's a single pipeline. It becomes a single threaded world computer. And if you're a computer guy, well, your computer can have multiple cores, as you may see, or it could hyperthread. So on that same core, it can utilize it for, a virtual core or two virtual cores or more to do different activities at any one time, as long as the software has been designed that way. So that's what essentially they're looking to do. They're looking to take the current blockchain, which is block after block after block, and to break it up just like this. So taking that world computer and breaking it up into thousands of different shards. So each shard in, for example, Ethereum's case, is going to have its own transaction history. It's going to have its own state. It's essentially its own blockchain. The only difference with Ethereum is that each shard is going to be run from a higher level beacon chain with its own proof of stake consensus mechanism, which each of these shards will be utilizing. So you can split the network in a number of ways. Now this could be done via, account numbers, location, whatever you like. The complexity of it though comes in cross-chain sharding. So if I have $50 on one shard and I need to send it across the network, which so happens to be an account on another shard, how do we go about that? That is one of the complexities of sharding. This here is a picture of Ethereum, of what they're planning to do with Ethereum 2.0. So we maintain this main chain with a proof of work, but we introduce this beacon chain, which is simply a coordination layer. And this is Casper and proof of stake, which is something that Vitalik has proposed recently. And this beacon chain here is essentially going to come up with random numbers. It's going to be coordinating. It's going to be doing a hell of a lot of things, actually. But what it's actually doing, if we go back, because that didn't work, is it's going to be providing each one of these shards some form of coordination. So each shard will have a validator at that point in time, and what the beacon chain will do is essentially come up and change that validator every so often to make sure somebody doesn't have full control of any individual shard. Because what they say about sharding is that if you were to have 100 shards, let's say, well, that would only take 1% of the mining power or the proof of work, if we were to apply it to that kind of network, to take over that shard. So obviously they need to use some form of game theory in this to make sure that the actors within the network are doing the right thing. Then down the bottom you have your virtual machine as normal. Now what they were looking at was 100 shards, which has now moved to around 4,000, and then once again I think they've actually updated it to around 10,000 shards. Now what this is means that it's exponentially growing that network in terms of quadratic processing, because each shard is going to be able to do, orders of magnitude more than what the single chain would in the past. And it means that when they finish working out their transaction history, they push that back to the main chain. We store that immutably forever. Happy days, we go on. The downsides obviously to sharding is that some people will talk about privacy concerns, some people will talk about centralization and the network effects, because sharding, if you were to corrupt one of the shards alone, is a lot easier than doing it obviously from a proof of work block by block perspective. The final one in the on-chain side of things is consensus mechanisms. So this is really, the low-level protocol kind of stuff, where if we look at proof of work now, every 10 minutes a block comes around. Well, what does that mean? Well, it's secure by design. However, if it's sequential in nature and it's a linked list, geez, spit it out, mate. It's a linked list of transactions. It means that there's no parallelization of those transactions, and we're not really getting that throughput that we desire. As we move down to proof of stake, proof of authority, proof of importance, or proof of elapsed time, we start to change the fact that everybody in the network has to do, all of the validation of the transactions, and we delegate some of that power out to a particular committee or to those with a particular stake, as in proof of stake, or in proof of importance, which is on NEM. They use your stake and your transactional behavior, and they kind of form a profile of what you're like. But what we're essentially doing is, instead of, let's say, 100,000 nodes having to validate, we might say only 4,000 do, or the top 100, etc., etc. And so we're limiting the amount of people that need to validate that at that core protocol level to make sure the network is in consensus. And as we move down the list, we get something like delegated proof of stake, which is what EOS uses. Now, delegated proof of stake does even more pruning of the amount of validators that it's required, and they only have 21 block producers which are doing all of that validation and governance, I guess, of the network's rules, because all consensus mechanisms are, or algorithms are, rules to the network in which we should be playing by. So like I said, proof of work, everybody's got to validate. Proof of stake, half, let's say. Delegated proof of stake, you pick. But obviously you need to incentivize and disincentivize these parties to make sure they do the right things by the network. That is everything to do with on-chain scaling. Sharding is something that I could talk about a lot more in depth, but essentially we're just breaking the network up into shards. Block size increases, obviously, but like I said, they have that upper limit. And then we have the consensus mechanisms, which is one of the more arguable topics as to, that decentralization, what you're losing in terms of security, decentralization just for a bit of speed, whereas sharding and block size keeps, those kind of two other principles in line. If you have any questions, let me know in the comments below, and I'll be bringing number 2 to you very shortly. As always, like and subscribe. Thank you.